Alright, we're going to go ahead and construct a polynomial that has the following roots, so it's going to be kind of a mess. It has a root of 3, and then it says multiplicity 2, and then a root of 2 plus 5i. So first thing we're going to do is we're going to just go ahead and make a table, and we're going to list our roots, and then what it looks like as a factor. So our first root is 3. And because it has multiplicity 2, we're going to have 2 of them. So that's where the x minus 3 squared comes from. And then one of our roots is x plus 5i. So remember, it's always the x minus the root. So it's going to be x minus the quantity 2 plus 5i. And we also know that complex roots come in conjugate pairs. So if a plus bi is a root, then so is a minus bi. So our other root is going to be a 2 minus 5i, and that'll give us 4 x's, so that we'll get a fourth degree polynomial. So then the other root is 2 minus 5i, so then the factor is x minus 2 minus 5i. Okay, and we're going to go ahead and multiply that all together. So x minus 3 squared, and then x minus 2 plus 5i, and then x minus 2 minus 5i. Okay, and this is just going to be kind of a mess. So first thing we'll do is we'll FOIL out the x minus 3. So remember, that's x minus 3 and x minus 3. So we're going to FOIL that out. That's going to give us x squared minus 6x and then plus a 9. Alright, and then we're going to go ahead and FOIL the other. X times x is x squared. X times minus 2 minus 5i is that piece right there. And then minus 2 plus 5i times x, that's that piece right there. And then we'll have negative 2 plus 5i times negative 2 minus 5i, so the negatives cancel. We have minus, I guess the order doesn't matter, but 2 minus 5i and 2 plus 5i. And then down here we're going to go ahead and make a comment here that a plus bi times a minus bi, that's a complex number and its conjugate. We're going to go ahead and FOIL that, so we get a squared minus abi plus abi, and then minus b squared I squared. So notice the abis, we can say so long to them. And then when we square I, we get negative 1. But there's already a pre-existing negative there, so we got 2 negatives going on, which makes that a positive b squared. So it's just going to be a squared plus b squared. Alright, let's go ahead and rewrite some stuff we have going on here. So we have x squared minus 6x plus 9, and x squared, and then we'll distribute that minus x to give us a minus 2x, and a plus 5xi, and then distribute the next minus x, so that'll be minus 2x. And a minus 5xi, and then we're going to use our property that a complex number and its conjugate, when we multiply them together, we get a squared plus b squared. So 2 squared is 4, 5 squared is 25. So that's where that's coming from. Alright, and we can see that we can say so long to this imaginary junk, and everything is going to be now real stuff. Alright, so we got x squared minus 6x plus 9. We'll combine our like terms, and we'll have x squared minus 4x and plus 29. And now this turns into something you would have done in like Math 05 or Math 0306. So we're going to go ahead and do x squared times x squared is x to the 4th. X squared times minus 4x is minus 4x cubed. X squared times 29 is 29x squared. Okay, so that was just multiplying this x squared all the way through. Now, because I don't have a lot of real estate, I'm going to write it this way. So we distribute the x squared. Now we're going to distribute the minus 6x. So minus 6x times x squared is minus 6x to the 3rd. Minus 6x times minus 4x is positive 24x squared. And minus 6x times 29 is negative 174x. So there we are, just distributing that minus 6x through. And finally we'll distribute the 9 through, so 9 times x squared is 9x squared. 9 times negative 4x is negative 36x, and 9 times 29 is 261. Alright, everything's kind of lined up, so then we're just going to write our polynomial out. So x to the fourth minus 10x cubed plus 62x squared minus 210x plus 261. And that is our fourth degree polynomial that has root of 3 with multiplicity 2, and then 2 plus 5i as a roots. And because of complex roots come in conjugate pairs, we got the other one of 2 minus 5i. So that's our polynomial, and that's kind of the procedure for doing that. This is one of the more complicated examples, but there's no particular step that's incredibly difficult. It's just, there's a lot of work and it's kind of tedious. Just got to practice it and you'll get good at it.